many things I want you to remember. I want you to remember that how do we get these stationary values again? Right? You differentiate and make it equal to 0. So when dy dx is 0, that is your stationary points, right? And how do you determine if it's a max or a min? You differentiate again, right? So we're going to apply those two principles again today. But of course, as I said, it's going to be for real life, real world problems, right? So number one, we need to remember when dy dx is 0, that's how we get the stationary point. And then if d2y dx squared is more than 0, we have a minimum. And if d2y dx squared is less than 0, we have a max. Right? So just as a quick review, before I put up the real world question, try this please. I want you to find the nature of the stationary values here. Find the nature of the stationary values here. Then we're going to apply the real world same thing. We have to get an equation, and then from the equation, we have to do it. Right? Find the stationary, then find the nature, right? Ready? Okay. Finish. Okay, how many bottom plate? I put come on. Right. Take your time, right? Find dy dx and d2y dx squared, right? Well, solve that one time. But before you make it equal to 0, you should actually say stationary points of two, right? But yeah, solve it now. Right. Now, second differential, d2y dx squared. So just differentiate again, differentiate 9x squared minus 4. Right? Now plug in the x values and see which one is more or less. My next is 4/9. You can do it here. 9. What's that? 9 and 18 is how much? 9 2/4 is minus 4. Right, so when x is 4/9, d2y dx squared is more than 0. I think this one I think. Is it maximum? And right, so just right minimum. Just right minimum. Right now, when x is 0, what would it be? Max. Okay, let's put it one time, right? Are you okay with that? Right, now we're gonna do a question with a real life situation. Right? That's it. So we're gonna do the same thing, but here's the problem, right? In doing these questions, the hardest thing is getting the equation to differentiate. Right, so we are all we did. Differentiate, solve it, differentiate again, and then plug in into value again. That's okay. Ready? Right. Take this piece of information, and again, a question like this could be an exam. Could be a SBA, right? An open tank, I'll draw one that's now. I'm gonna draw it so you know what you're working with, right? It's something like this, right? I can't draw these things together, but right, it's an open tank. It's an open tank with a square base. Yeah, we're writing. So the down here is square, right? So let's call here X, let's call here X, and let's call the height H. Right? So an open tank with a square base is to be made from a thin sheet of metal. So we're gonna make something now. I give you a sheet of metal and I want you to make that from an open tank with a square base is to be made from a thin sheet of metal. Right? Basically, the thing is you want to make it, but you don't want to waste metal. All right? Full stop. Full stop. Find the length of the square base. Find the length of the square base. Find the length of the square base and the height of the tank so that the least amount of metal is used. So that the least amount of metal is used. So that the least amount of metal is used. The least amount of metal is used to make a tank of capacity 8 meter cube. To make it tank, with a capacity of 8 meter cube. Right? So any equation and all that information? Any equation they give you? No. All they tell is this is the base is square and the volume is 8 meter cube. Right? But they gave you a keyword there. Is it a maximization problem or a minimization problem? Minimization, right? So it appears to be a minimization, right? Right, so we know it's something to do with minimization. Right, but before we do this, we need an equation. Right? They're giving us a sheet of metal, right? They give us a sheet of metal, we don't know the dimensions or anything like metal. But we want to use as little of the metal as possible. So question, what do we need or what will determine how much metal we use? Surface area, and the surface area here will determine how much metal we use, correct? So let's see if we can find, because we need an equation. Let's see if we can find total surface area. Right? The piece is what? The top open, right? Is an open tank, is an open tank. So the area of the piece is what? X by X, right? That's okay. And then all the sides are what? You have 4 sides, right? All the sides are what? X by each, and it have 4 of them. That's okay? So we have an equation. Have a slight problem they make you. We have a slight problem with that equation. I want to differentiate it, right? So I'll differentiate dA with respect to what? What the problem is. We have 2 variables. We have X and we have H. We can only differentiate if we have 1 variable. Here's how I think a little bit. How we gonna get rid of that variable? How we gonna get rid of one of them, X or H? Divide by H, but then H just come here and here. Question gave you a little bit of information, I guess. What else they give you? They gave online. Are you okay so far? If you're confused, just let me know, right? What they give you, John? They give you volume, right? They said the volume is 8. How you find volume? Right? Base by height, right? So that will be length by breadth by height is 8. Correct? So H is what? 8 over x squared. So now what we can do with this H? Put it in there and then differentiate. See that, Nathan? Next, Nathan. See what I did? So I have this surface area equation, but I have a big problem. I have this H here I want to get rid of. So I use the information they give me and I get rid of H. Right? So I have A is equal to x squared plus 4x all over 8 on x squared. This x will cancel here, and I'll get x squared plus 32 over x. Right? So now A is equal to x squared plus 32x to the minus 1. Can I differentiate this and get the x values and then see which one is minimum? See now, Rima? So I now reach a point where I can differentiate. Okay, copy it down. Differentiate. When you get your x values, see which one is minimum. And then you have x, then find H. Right? There's a lot of thinking. You gotta have a diagram because it might give you a diagram. You have to develop equations. So you're using one bit of information into the next one. Then we can differentiate. Go ahead. Bye-bye. Nicasio. Student Cassie? Student Cassie now? Well, blind in COVID. All right, online. So where we reach now, I want you all to differentiate and find the stationary values. Find the stationary values, right? And then see which one is max and see which one is min. So besides being able to differentiate, you gotta be able to simplify too. Because those equations don't have some tax at all. Like fraction and all kinds of. I got differentiate and solve. Did they give you the exact value? To you too. They give it up. Take your time. Take your time and differentiate it, bring down your power minus 1 and then solve it. What you gonna do? When you differentiate it, what you got? Nice. Right? So now you're saying dA dx equal to 0. When dA dx equal to 0, stationary points occur. Right? So now you have to solve this. X to the minus 2 means x squared, right? Right? What is the fraction here? Multiply it out. Multiply by x squared. So you'll get 2x cubed minus 32 is 0. Right? Go to calculator and you'll get 2.1. 0.5. Right? You only have 1 point, so you guarantee this point is what? You only get 1 point, so you guarantee is what? Minimum. Okay? But ideally, you have to show them, right? So d2y dx squared, you have to show them as a minimum, right? Because sometimes they might get 2 points. Right? d2y dx squared is 2 plus what? 64 x to the minus 3. Right? Plug in the value and you will get it more than 0. Therefore, it's a minimum. Right? What's what I did? I differentiate again and then I just plug in this value to make sure it's minimum. Okay? So we found the x value. So the x value is 2.5 meters. So what is the h value? What again, the h value, Caleb? You follow how I got the x value? How again the h value? What do I have? Oh. I know h here. What equations you have? H over x squared. So h is 8 over x squared. So it's 8 over 2.5 squared. How much? So those are the heights and that's what it is. Correct, make any sense? What y'all think? Are you okay with that? Copy down, get next one. Next one. Okay? Sure. Next one, go on to the next one. That's all to make sure I go. Make sure you're good, right? Next one is for you. Any questions online? All right, let's go again. Same similar thing, right? Similar thing, the information that they will give you will vary, right? So let's try this one out. Oh yeah. Remember, area is always what? Sorry, volume is always area increased by the height, right? Volume is always up. All right, find the least amount. Try this one. Find the least amount of material needed to build find the least amount of material needed to build an open right cylindrical vessel. Open right RIGHT cylindrical vessel. With a capacity of 400 pi cm3. With a capacity of 400 pi cm3. All right, take care. right? And it open on top, right? Top here open. Okay? Top of the cylinder open. I find volume again. Area of the base by the height. Copy down. Right? That's all they give you. So they want you to find the least amount of whatever problem it is. Yeah. Minimum, right? Minimization. Okay, have fun. Do that tomorrow. Volume of cylinder is area in place by the height. Pi r squared by height. I'm gonna give you that. Take it out. You know, volume of a cylinder is pi r squared by height. Right? That's the area by the height. Remember the top is open. Okay? So you gotta get the area here and the equal. Let me say what. Do one thing now. Fine. For those who can't remember, if I were to turn this, this becomes a cylinder. If I were to open it out, it's a rectangle. Remember that, right? Go ahead, do your thing. Move it out. Right? So the same procedure. Find this, make a substitution, differentiate, work it out. Chi, subsequent chi. Hey, what do you think now? So be ready, come. Come on, you go on. Finish? Where you going? Right, Raymond. Sorry, Raymond, next one is yours. Severe, let's go. Let us go, let us go, let us go. So where do we start, Severe? It's a minimization problem, right? Right, so we need to minimize, right? What do we minimize? Area, volume. Area again, right? So we're minimizing total surface area. Or the total surface area, Severe. Yeah, what would it be? Pi r squared, because you have this circular part here, plus what? Right. When you open it out, right, like this, when you close it, so I'm gonna turn it into a cylinder, right? So you have a width and a length. If I turn this into a cylinder, right, your width is your height, and your circumference is your length. Correct? Yeah. So it will be 2 pi r multiplied by h. Right? kind was the problem there? What's the problem with this equation here? Two variables. Phi is a constant, right? So how do I find h? What to do to find h? You have the what? Volume. So I can put the volume here and find the h, right? Yeah. So we know that V is equal to 400 pi is equal to pi r squared by h. So I can make h a subject and I'll get 400 over 400 pi over pi r squared. So h is 400 over r squared. You give it up? Right? Next step, Rima. What to do? What's the next step? How do I simplify this? What to do? What to do? I can multiply this by anything. 2 pi by anything, the r ending up with the r's. This r will cancel with the square. And then what? 2 pi by 400 is how much? 800 pi. And if I bring up the r, it becomes r to the minus 1. If I were to bring it up, okay? And then we can differentiate one time. Right? What is the ADR then? What is the ADR? Huh? And to differentiate in this? Huh? Can we substitute yet? Can we substitute H already? Can we get this? Yeah, differentiate pi r squared. What do you get? Okay, start back from here. Differentiate it, and you're following the same steps like that type. Same steps from there. Are they okay online there? Amit, Elizabeth? You're follow what's going on? Sure. Okay. Finish it out. Let's see what you got. Oh yeah, differentiate there. What's it? So that pi confused it. Pi is a what? Pi is a constant, right? So Rima, what's the differential of pi r squared? Pi is a constant. Try something. What would it be? Differential of pi r squared to pi r squared. Yeah, like the same thing. What's the differential of r squared? What's pi r squared? Pi is a constant. Right? So the differential of pi r squared is 2 pi r. Pi is a constant, right? Okay, that's multiplying 2 by pi and leave it like that. I don't want to get I know get a book or something. Right? Even if it depends the wrong, that's all right. At least it went through the other steps. Right? And we can go back and fix the differential after, right? Elizabeth, again, sure. I'm to that. I ain't sure about the differential. How to solve it. Right? Get the diffraction and solve. Multiply, get the diffraction. What's the differential of 800 pi r to the minus 1? Okay, then, what again? That's after the differential. About one of the r cancel. So what's the differential here? Minus 800 pi r to the minus 2. And now we have to find for dA dr equal to 0. So that'll be 8, sorry. So that'll be 2 pi. You might have to stop watching. You have to learn to try. Okay? But now what's your book looking nice, so we'll be able to get it right. So even if you get this wrong, you should be able to try what? Even if you get a differential wrong, I want to see you try all of this. So at least you know how to do these things to recognize the problem is here. Right? But if you stop here, then you don't know where your problem is. Okay? What's the differential of, sorry, to simplify this, it will be 800 pi on r squared is 0. What do I do now to simplify this, Raymond? Can't cancel anything. Same thing with the that side. Do you like to work with a fraction? No, we'll write it down in red. I don't want to work with a fraction. So what to do? No. Why did they? Multiply by the denominator. Right? It's the same thing from there. So that'll be pi r cube minus 800 pi is. What are you doing next? Okay, that throws and solve for r, right? How much will I get? 7.4. That'll be centimeters, right? What they ask for again? The least what? The least amount of material used. Right? So we just need to plug back in the value here. So we can give them the area. They want the least amount of material used. So put back the value here to get to. To figure out R already. So A is equal to pi by 7.4 squared plus 800 pi all over 7.4. Okay? They asked how much. They didn't ask the R and H. They want to know how much, so it comes back here. Much is that? How much? 800 centimeters squared, right? Okay, follow what to do. Okay, we do this steps again. What's the first thing we did? Huh? Well, the whole thing. I give you the question. What's the first thing we did? Right? Take the info and develop the implication. Right? After we do that, the problem was what? Two variables, so we had to get rid of using. Right? After that, Nathan, Mohammed. After we substitute here for the next step. Differentiate, right? Put it in a form so you can differentiate. After you differentiate, what are you doing? Make it equal to 0 and solve, right? And after you get your R value, answer what the question is. What would have happened if you have 2 R values? Next, Nathan. If you end up with 2 R values, what to do? Find which one is min, right? Then move it up. G then. You can handle this. Or you're not sure what? Which part? You guys know how to get this? So you got now sum to the H. So you can simplify from here to here. You can differentiate. Right? So remember differential is take the power, bring it in front, minus 1. Take the power, bring it in front, minus 1. That's all. Pi is a constant, so don't do anything with pi. Right? Next one. Yeah. We have a next one to do. Yeah. The good thing is I haven't seen them in the exam. But still giving them. Type 2, yes. Right, ready? Let's go again. A rectangular field. I am giving you no diagram this time. You do your own thing. And I want to see your working. Online as well, get away with. I had to find out how to solve this problem. What is it? Other lessons, like what a teacher would do with you online. You'll call the individual, let's leave you. What is it? Kind of picture the work. And what else? Make it point the camera and show the book. You'll have to start with the camera thing, right? Under the camera. And then if I take a picture and stand the, but also the phone camera, I will send a picture. There's a time to wait on that to be the problem. Huh? Yeah, we had to change up some things this year because some people, but when they come to crash course, they don't do nothing. And then every online course class, when they come crash course on one thing. All right, a rectangular field is surrounded by a fence. A rectangular field is surrounded by a fence. Rectangular, right? On 3 sides, on 3 of its sides. A rectangular field is surrounded by a fence on 3 of its sides. And a straight hedge on the 4th side. A hedge is like a hedge is like plants, right? So yeah, you have plants on one side and the next 2 sides is fence. Close up. Oh. A rectangular box, a rectangular field is surrounded by a fence on 3 of its sides and a straight hedge on the 4th side. Straight hedge. a straight hedge on the fourth side. Blah, full stop. Blah. If the length of the fence is 320 meters, remember rectangular. If the length of the fence is 320 meters, find the maximum, underline that, find the maximum area of the field enclosed. 320 meters. If the length of the fence is 320 meters, first, comma, find the maximum area of the field enclosed. Huh? Because it's only 3 sides of fence. In the next piece, you don't need it. Okay, so it's a side, 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 and then you have the hedge there. Come on. So we're going to same thing. Go ahead. What do you want to find? The maximum area. So your first equation has to be here. Everybody's doing the thing on what you're writing. If you had to write Cambridge, write something. I want to see what you have. Online, take a picture and send it from up. You'll have 8 minutes to work out this. 8 minutes. Oh yeah, start a joke. Yeah, go say I draw a diagram. Say. Go ahead. Why? There, everything you need. It don't matter. Just call one side X, one side Y.
Yeah, that's good.
Right, but one side have a hedge. 3 sides have a fence and one have a hedge. Huh?
Yeah.
Don't matter. Go work out. You put it wherever you want. You do your own thing. Huh? It don't matter. You say even one side has Y and one side has X. I mean, the long, all right, here's the, let me make it easy. The long side is Y and the short side is X. Okay?
So it's a white side or X side. That's
What?
so it's a white side or X side.
Don't matter. That don't matter.
Really go.
In the end, you'll get the same answer. All right, here what? To ease up all your worries, I will tell you where the hedge is, and I will tell you where, right? But it don't really matter, right? In the end, you'll get the same area, right? Here's what I'm doing for you, right? This is your hedge. That's your fence, that's your fence, that's your points. Here's Y, here's X, here's X. Why? Oh Lord. Right, that's it. Okay. So ask nothing again. Do all the good. Do all the things. Let's try. Let's try to do what we are. Like online, pick how you're working, right? When it's again, I'm gonna check out Jason on here.
Set from there.
Yeah, Jason on study moving on from the field. Today. All right, Jason not looking good there.
Oh,
Not looking good there, Jason. You know the facts, all right?
yes.
Right, he's doing a little thing here, he's doing a little thing here, and he's solve it there. And he gets. Good job, Jason. Go get the details, right?
So I got equation to get the so
Yeah, equation.
what is what type of equation?
I know, tell her that's not. Rima, come on. You come on the board, Rima, under this cool question. Come on. Come on the board. If you want to make a mistake in the book, come on the board. You can erase it here. Come on, kid, how far you reach? Right, hurry up, so. Get your area, get your variable. Outside, right, it's outside, right, it's outside. Bye-bye. Howard. Tell me, Howard. Area question way easier than this. Area question, this one easier than this. What is my area? Right, and what's the length and what's the breadth? Right. So you want me to write where you should write, okay, I'll write it there for you. Area is y by x, nice, what's the problem then? Problem is two variables, right? What you going to use to get the next variable? Raymond. What you going to use to get rid of one of the variables? What you got here? Look at the question. What I gave you?
Okay.
Alright, so 320 is what? Raymond, fix it. He said 3y, I wrote. Close it. Yeah, 320 is what? 3y is 320 is 2y plus x. See enough? Right? 2y plus x. Jason make x the subject, which I find was nice. Right? Because you know I divide by 2, right? So x is 320 minus 2y. come back here. What I would do there? What I would do? I would get rid of one of the variables. Right? So A is equal to 320 minus 2y. What's the next step? The next step.
Three, cancel.
This one in. Three more. What's the next step? What you tell me? What's the next step? No. Okay, so how are you doing now? How are you doing then? Multiply it out, right? Correct? What's the next step? Half the area. What's the next step? Right? Differentiate. Differentiate. Next step. It's like you first, it's not a little bit more. I'm done. They are now. It doesn't meet up. Right? And last step. What do you ask for again? The maximum area. Right. How you know it's maximum when you get one answer, right? When you get one answer, but really and truly, we should double differentiate and just make sure. All right. What is it? Understand that? Right. Next topic, get the differentiation. Huh? Next one. Emirate, right? Good job, Emirate. I didn't see some people online, right? There's a bet on a few others. Are you okay with it? Right, you'll see the pattern, right? But of course, scenarios can change where it doesn't. What doesn't change is this. Give an equation. In the equation, they will not give you one of the variables. Well, they'll give you two variables, gotta get rid of it. And then simplify and work it out. All right? So your project might be just like that. Like in my school, I just give them a piece of cardboard and they have to maximize volume. So they have to build like pots. I'll maximize the volume based on dimensions that they got. Right? And I'll take it. And then they will make it take a picture and that. All right.